The next questions have parabolas, right? Because square root of lines, technically you've done already. All of your transformations unit with square root dealt with lines. But now we can do square roots of parabolas. The rules stay the same. Wherever your y values are 0 or your y values are 1, those points aren't going to change. So if I look on my graph, can you see that here and here, my y values are 0? Here and here, my y values are 1. Now I have to get my screen perfectly set up for this so that I can do this accurately. So between 0 and 1, it has to be slightly above. Now this is going to be hard. That's about as slightly above as you can do with it so sharp, without going back in time and losing a half a mark. Same thing here. I want it slightly above. It's almost going back in time. So that's why I say it's hard to do. They would accept that, right? It's not like you're like really bubbling back in time like that. That would be bad. Okay? So that should go away. And then after, we could take some other values, like square root of 4 is 2. So square root of 4 is 2. So it has two different parts.
How do you know which side it's facing to? Why couldn't we go like this?
Well, because this part in the middle is where your y values are negative. And can you take the square root of a negative? No. So this section which I've highlighted here will not exist on the square root graph because your y values are negative. Yes?
He's saying, why does it go over the line, like, from the inside of the parabola, not from the outside?
Oh,
Like he's asking, like, why does it not go out from the outside of the parabola, not the inside?
why does it go this way
Yeah.
instead of going which way? This way?
Yeah, that's what he's asking.
Well, if it went this way, so if I went this way,
Out.
okay, this part here matches up with this part there, which can't exist. Those x values can't exist. Because that's where your y is negative and you can't take the square root of a negative. When you're thinking about, so what I did is I said, I know this point on my red graph is the y value is 4. So that means on my blue one it's going to be 2. Because I can take the square root of 4, it's 2. I know that this point on my red graph was negative 4. I can't take the square root of negative 4, so I can't draw anything on the blue graph. Again, we just think about above and below, not inside and outside, not left and right. But if I do this section again, so here and here. My red graph, I have to do something above that. So if I wanted to put a point above that, it would have to be, in this case, to the right of it. But that, I'm not thinking to the right or the left. I'm thinking if I take a red point anywhere on there, like that point, and I have to draw a blue point just slightly above it, it's going to be there. Like if I'm just going straight up and down, and I put red points and blue points, it's really hard to do just slightly above. And then you have to connect those blue points. Yes? Well, your x coordinates, so here I'm starting at 5 and going to 6. If I start at 5 and go to 6, if I go this way, can you see that I'm going backwards? Whoa. And if your x-axis was time, then you would be going backwards in time. And often your x-axis does represent time, so maybe that's where I drew that analogy back in time from. So here, with our final graph now, we can say, what is our domain? Well, our domain has two parts. One part is when x is less than or equal to 1, and the other part is when x is bigger than or equal to 5. So when we have two parts, we can either write it this way, x is less than or equal to 1, or x is bigger than 5. That's set notation. Or if you used interval notation, you'd say, starting from our left, we start at negative infinity and we go to 1, square bracket included, or we start again at 5 and go on forever that way. So you can choose which of those two notations you would like to use. Do you have to know them both? Well, if there's a multiple choice question where one of them is used and the other one isn't, you do have to know them both for that. I will never ask you state the domain only in set notation. Okay, if I say state the domain, you have the option. Same thing with range. Your range here, your y values are bigger than or equal to 0. You could write that as 0 to infinity. Our second example. We want to do the square root of this parabola. And so wherever it's 0 and wherever the y values are 1, those points won't change. Are there any other values you can square root easily on the red graph? 4. So, and 9. So here's 4 and 4. So those would be 2 and 2. And here is where the y value is 9. That one's really easy to do. That's where it's going to be 3. Between 0 and 1, your graph has to be slightly above the red graph. So if you picked a point on your red graph there, on the blue graph, it's got to be straight up from that. It's hard to do on the smartboard. So again, this is going to look like that. And it's really hard to show that it's above the line when it's so steep. What do you mean, why can't it cross? Like this one go this way forever and this one go this way? Like this? Well, again, this part of my graph connects to this part of my red graph. And that part of my red graph is negative, so it can't exist. Our domain for this one in set notation goes from negative 3 to 3. In interval notation, you would just write from negative 3 to 3. And our range goes from 0 to positive 3, which you could write like that. And questions for this one? Number 8. So I'll give you a little bit of time to finish 5 and 8.